Hello. In this chapter, we're going to look at solving more types of equations and inequalities. In particular, we're going to first look at linear simultaneous equations. So you would have seen this at GCSE, but simultaneous equations, essentially, we have multiple equations with the same variables. So, for example, 2x add y equals, I don't know, 7. X add y equals 5. These are two different equations, right? Equation 1, equation 2. But the two different equations that are have x and y, so the same variables, but with two different equations. And so what we can do is, in this case, when we have multiple equations with variables, we could solve them to get the unique values x and y that satisfy both equation 1 and equation 2. And there are two methods to do that. The first one is substitution, which is going to be the one of the probably the more important method as we go on throughout the course. But substitution is essentially we rearrange one equation to get in terms of one variable. So let's say for equation 1, if we rearrange this to get y on its own, for example, y would be 7 take away 2x. Okay, hopefully you can see that, right? So I've got y on its own, but it's the exact same equation, right? Then I'm going to then this is where substitution comes in. Now I'm going to substitute into the other equation. So into the second equation. So wherever y is, I'm going to replace it with this. And the whole idea is now it's one equation with one variable. So x add y, which would be 7 minus 2x is equal to 5. And the whole idea is we reduced it to one equation with one unknown, which we can solve, right? It's a simple equation. If I was to expand this, well, not expand it even, but if we had if you simplify this, x minus 2x minus x, and then plus 7 is equal to 5, then x then would be 2, right? Cool. Um, okay. But then now if I know what x is, the whole idea, well, we know what y is in terms of x, right? We that's our substitution here. So therefore, we can then say y is 7 minus 2 lots of 2. That's going to be 7 minus 4, which should be 3. Therefore, we got a unique solution, which should be x is 2, y is 3. Okay, so the whole idea is that these values are the only values that make both equations correct. Okay, so they solve both equations. And so that's the whole idea, right? Is to find the values such that it makes every equation true. Okay, as to both equations. We can also look at another method called elimination. So what this is, instead of substitute, to rearrange to plug one variable into in terms of the other, and then substitute the other to get one equation. But the whole idea is we still want one equation with one unknown, so one variable which we can solve like this quite nicely. But instead of substituting, what you're going to instead see is how we can look at the two equations and see how we can cancel one of the variables out. So I'm going to write this again. So 2x plus y is 7, x plus y is 5. Okay, now the whole idea is I want to do some sort of operation. Usually I'm going to add or subtract the two equations, and I'm going to get rid of one of the variables. And so again, I have one equation and one unknown, such as x. Well, I want to get rid of the y, for instance. Well, how am I going to do that? I can either add or take away the equations, right? Well, I think if we add in y in both equations, what if we take away the two equations, right? So if we say equation 1 take away equation 2, what I'm going to do now is because I have positive y here, and then I have a positive y here. So if I do y take away y, that cancels the y out. So what taking the two equations away, we get 2x minus x, right? but that's going to go to just x, right? And then I have plus y take away y. But the whole idea is then that gets rid of the y. So I'm simply left with x equals, and then 7 take away 5, which should be x is 2. And what do you know? We get the same solution there. But then x is 2, but then once we found the solution, then you could just substitute it into either equation. Once you found one, once you found one variable, right? So when x is 2, we're going to have two say substitute it into 1, right? So I'm going to say sub into 1. Then I found this x value, so 2 lots of 2 plus y is equal to 7. Well, that be 4 add y equals 7. Therefore, y is 3. And there we are. We've got the same solution there again. Cool. So that's the whole idea, right? So with both methods, the whole idea is ultimately you just simplify it to one equation with one variable, which you can solve, right? However, there's different ways of doing that. You can either substitute it, um, which is a more of a substitution is a better method. And you don't have to think about how I can get rid of the equations in certain way, because you can just rearrange, right? But that's one method. You can either substitute one variable in and then explicitly substitute it into the other equation to get rid of it that way, or you can eliminate it and be a bit clever and see how can I add or take away the equations to get rid of a particular variable. So you want to make the coefficients match, right? So you're going to want, so because we have plus y and plus y on the two equations, we can just take them away such that y minus y gets rid of the y's. Okay, so that's a brief overview. So let's have a look at some examples then, right? I'm going to get rid of this now. So first of all, it's asking us to solve the equations. 2x plus 3y is 8. 3x minus y is 23. Um, okay, well, I'm going to do the one of each for one that's substitution, one that's elimination. I'm going to do substitution first, okay? So you can call that equation 1, equation 2. Doesn't particularly matter if you label it, but I think it makes it a lot clearer what exactly you're doing. Anyway, well, again, the whole idea, I want to rearrange one variable, right? So what, y or x in terms of something, right? And then I get rid of it. Well, the best approach is actually probably this minus y because that's the only that's basically y on its own, right? I don't have to worry about a number in front of it. So we can then consider equation 2. So if 3x minus y is 23, then we can say y, if we add y to both sides, is 3x and then take away 23. Okay, so I move the y to the other side and then I move the 23 to the other. There we are. Well, now we've got y in terms of something. So we can substitute y into the other equation. We can't substitute it back into equation 2, right? Because that's what we used in the first place. If you were to do that, you'll basically just get 23 equals 23, which isn't helpful. It doesn't tell us anything. You have to substitute, in order to actually solve it, you need to use one equation and then substitute it into the other. Okay, it has to be different because the equations are different. They're telling you different things. Okay, so just need to be careful of that. So because we used equation 2, we're going to substitute it into the other equation. So I'm going to say sub into 1, or substitute y into 1 to be more precise. Okay, well then 2x add 3. Now the y goes to 3x minus 23, which again is the beauty of this method, because that gets rid of the y, just again in terms of x, is 8. Then we can just solve it. So let's expand. So 2x and then 3 lots of 3x is 9x. 3 times 23, that'd be minus 69 equals 8. Then I can say 11x is equal to 8 add 6, that'd be 77. And then x is simply 77 over 11, right? Which would equal 7, right? Cool. But then that's x. But But now we've found our x's, we can either substitute x into the equations again, right, to get y on to get y, uh, or we could be because we already know what y is exactly. We already rearranged it here. We can use this equation instead. So then y would be 3 lots of x, which would be 7. Take away 23, which then that will go to 21 minus 23. That'd be minus 2. Okay, cool. So that's our solution then. So the solution is x is 7, y is minus 2. Cool, great. Okay, let's have a look at the next question then. We have 4x minus 5y is 4, 6x add 2y is 25. I'm going to do this one by elimination, doesn't matter, but just want to show both methods. You call that equation 1 and 2. Again, they're different questions these times, so they're not the same. But anyway, just for sake of clarity, I'm going to label them 1 and 2. Okay, so I want to I want to basically subtract or add the equation somehow to get rid of a letter. Well, it's not exactly clear this time because if we just add them, because all the coefficients are different, so 4 and 6 are different for x, and minus 5 and 2 are different for y. So I can't just simply take or add them away, just get rid of a letter. So what I need to do instead is I need to scale the equations to match to make the coefficients match. And to do that, we can consider lowest common multiples, right? So if let's say I want to get rid of y, okay? Okay. Well, if I just added equation 1 and 2, minus 5y and 2y is going to be 3 minus 3y, but that's still y. That's to get rid of it. So what I need to do is actually scale both equations by considering the coefficient of the y, because y is what I'm choosing to get rid of or eliminate. So I need to make these numbers match. I need to times minus 5 by something and 2 by something to make them match. And that's when you just consider the lowest common multiple, right? 5 times 2, 10. So that's what we're going to do. So I'm going to times the first equation by 2. So then I'm going to get 8x minus 10y is 8. And I'm going to times the second equation by 5, right? So then 6 times 5 is 30x. 2y would then go to 10y equals 125. And now we got matching coefficients, right? For y, which allows us to very easily just then add or take them away, okay, to get rid of the y. Okay, cool. So that's a general strategy, right? If you do not have matching coefficients, you can just times the two equations by the numbers, right? So the first equation to make the coefficients match, I times it by the other number, which would be 2, and then vice versa for the second equation. Because I have 2, I can times by the other coefficient, 5, to then get 10, so they become equal. Obviously, the different signs, but as long as the numbers are the same, it's 10. That's what I care about. And I call these equations 3 and 4, again, for sake of clarity, but these are equivalent, right? Because all I've done, by the way, is just times it by both sides by a number. Remember, for any equation, say, very simply, 2x plus 1 is 4, for a very simple equation. Remember, if I times by a number, say 5, to both sides, because that's what I've done, that's the exact same equation, right? Remember, think back to Jesus C. 10x add 5 is 20. These two are exactly equivalent equations. I've not done anything there to alter anything. I've just scaled it. Okay, that's what I've done there. Like with fractions, right? 4 over 2, I can simplify, or 4 over 6 is the exact same as 2/3. Okay, I just scaled it. Anyway, so we've got these two equations. I notice I matched the y's now. Now to get rid of the y, I can either add or take the equations away. I notice I have a minus and a plus. Well, actually, then if I add the equations instead, I then get minus 10y, add 10y, that goes to 0y, which is 0. So that gets rid of the y. So adding them, because they're opposite signs, but then I get 8x add 38x, add 30x, which is 38x. Then the y's cancel, so it's just 38x is 8 add 125, which should be 133. Okay, but then x is just simply then 133 over 38, which should be 7 over 2. Cool. So that's the value of x. Well, then y, then to find y, because it's now found x, so I can just substitute x into either equation, right? Any equation to then find y. Let's substitute it into equation 1, because I don't know, it's a smaller. Actually, no, let's do equation 2, because it's 2y. I have 7 over 2. That I'm cancel the fraction down. It doesn't really matter. I'm just thinking of what's best. Anyway, so I'm going to substitute then into equation 2. So I'm going to say sub x into 2 to then get 6x, which would be 6 or 7 over 2. Add 2y is 25, right? Well, then that's just an equation for y to solve, right? So then if I simplify this, so 6 times 7 over 2 is 21. And then 2y, if I get rid of the 21 before, therefore y is 2. Cool, so therefore we found x and y. So the solution is x is 7 over 2, y is 2. Great, there we are. Cool. So that's our solution there, therefore. And you can check your solution, because if you substitute these two numbers, right, into the equations, both of them, they both should be correct. If you substitute x and y into here, you should get 4 equals 4. And for the second equation, you should get 25 equals 25 if you plug in x and y. Okay, cool. Let's have a look at another example. Solve the simultaneous equations. 2x minus y is 1. 4x add 2y is minus 30. Cool, 1 and 2. I'm going to solve by substitution. So the first one's probably, I'm going to substitute y, because that's the only one without a number in front. So it makes it very easy to rearrange. So y is going to equal 2x minus 1, right? If I rearrange equation 1 here, right? Hopefully you can see that. So by adding y to both sides and then getting rid of 1 to both sides, I get 2x minus 1 equals y. Cool. So that's equation 1. So then, because that's from equation 1, I need to substitute it into the other equation to get some actual information out. So I'm going to sub y into the other equation, which is 2. Then 4x add 2 lots of 2x minus 1 equals minus 30, which obviously gets me an equation just for x, right, which I can solve quite easily. So then 4x add 4x minus 2 is minus 30. Then 8x is going to equal minus 28, right, if I add 2 to both sides. Then x is minus 28 over 8, which would be minus 3.5 or minus 7 over 2. Cool. So that's the x, and then I'm going to need to find y by substituting x into an equation. I'm going to substitute it into here, right? So then y is 2 lots of minus 7 over 2 minus 1. Well, that'll go to, if I put that in the calculator, I then get minus 8. So there we are, that's our a solution. So then our solution is x is minus 7 over 2, y is minus 8. Great stuff. Okay. Okay, before I move on, like with quadratics, the calculator, which you'll be expected, this sort of calculator you'll be expected for A level. Um, um, Also, like with solving quadratics, your calculator will also be able to solve. There we are. We'll also be able to solve simultaneous equations, right? So as you can see here, we can solve a quadratic, right? Ax squared plus bx plus c equals 0. We discussed this in the quadratic section, but your calculator can also solve um, simultaneous equations. So how am I going to do that? Let's check one of our examples, right? So let's check example one, question A. So to find this out with your calculator, we can go to menu. Again, equations, functions. It's yeah, that is an equation, so it's going to be A again, like with quadratics. Uh, well, with quadratics, we looked at polynomial because it's the type of polynomial equation. This one we want option one instead, which should be simultaneous equations, which you've got here. Number of unknowns. How many variables is two? Because we only have x and y, and therefore we input our equations. So we can see if for A, 2 and 3y would be 8. 3x minus y, that would be minus 1y, is 23. Then if we solve it, it tells us x is 7. Let's have a check. Yep, x is 7 and y is minus 2. Great stuff. Okay. And then we can verify the other equation, right? We have 4x minus 5y equals 4. And we also have 6x plus 2y is 25. Okay. And so x, we get 7 over 2. Yep. We can see here we get 7 over 2. And y, if we then press equals, we get 2. Great stuff. So we get the equation again. So we get the right solution. Again, the calculator is a very powerful tool, right? And the calculate what properties. All your calculators in your A-level exam should have that property to solve simultaneous equations. This one is a class whiz, but the examiners will anticipate you will be able to solve equations like this on your calculator. Okay, so just to echo again, if we go on them, click the menu button, which is all the functions on the calculator, then you go to A, which is equations, right? Because these are simultaneous equations. That'd be option one afterwards. Then two unknowns, usually for A level would be two, which should be X and Y. And therefore you input your equations from there. And as you can see, once you put the coefficients in, you put the equations, you get the solution instantly. As with quadratics, I always say you should solve it manually, but then use your calculator as a checking tool. Unless it tells you to write down these solutions, which means they just expect you to calculate to write down the number without having to show any working. You should expect to show you working, right? Um, so don't just use the calculator to write down your answers. My best suggestion is to use it as a checking tool. Okay, as I've done there. So show number working first, and then the calculator very quickly gives me the answer, which I know to check that I've done it right. Okay. But yeah, so cool. So that's just another thing to be aware of. As you can see in the last section with quadratic, again, we looked at solving quadratic equations with the calculator. Now we can solve simultaneous equations with the calculator. Cool. Okay. So we're going to move on then. We're going to look at some more examples. So have a look at this question. We have 3x and ky is equal to 8 and x minus 2ky is equal to 5. So k is just another, we're solving for x and y, but k is just another number. It's a constant, right? Which means it's not exactly like something it's solving for. It's just a placeholder number, right? Imagine k is just a coefficient, okay? But what that means is we can't use the calculator because the calculator will only work for actual numbers we can input, not like missing letters, okay? So this, for example, this is a good question to show why you can't just be reliant on the calculator because some questions you can't use the calculator, and this is one of them. So we do need to use our skills that we just learned. Okay, so we've got this equation. It's asked us to part A to show us that x is 3. So Again, simultaneous substitution or elimination. Well, we need to solve for x, right? So that's telling us we need to get rid of y. But it's not just y, we have ky. So we want to get rid of ky, really. Um, so I think the best thing is to use elimination. So if I call that equation 1 and 2, I want to get, well, this is minus 2ky on the second one, but I have ky. So I can scale the first equation by times it by 2, right? To then get 2ky. So then we have 6x and 2ky is 16. If I double the first equation, then the second equation is as it was, right? X minus 2ky is 5. So that's equation 3 and 4 here now. Okay, we now have 2ky. I have the same number. I have the same number of y, right? Which means I can simply get rid of them. So I can get rid of the whole y business, right? But how am I going to do that? Well, I can just add both equations because I have plus 2ky here and minus 2ky there. Cool. So then if I do, say, 3 add 4, add the two equations, then 7x, 6x add x is 7x, 2ky take away 2ky is 0. That's equal to 16 add 5, which is 21. Therefore, x then, if I start, is 21 over 7, which is 3. There we are. Great. So we've done that then. Cool. We could alternatively do substitution. However, it would be messy because you'd substitute for what? Well, actually, you'd actually want to substitute for ky, wouldn't you? Because because ky is here. You want to get rid of the ky because k is also a missing number. Um, but if you work substitution is a bit fiddly here, right? Because if you substitute for what rearrange for y, say for the first equation, right? You have something like 8 minus 3x over k, or you could times by k to get ky, and then substitute it into that. It's a whole mess, okay? I prefer elimination here, and hopefully you can spot what I've done there, right? By simply matching the coefficient of y to get rid of y. I know I wanted to get rid of y because it's telling us first to solve for x, right? So that's telling me I need to get rid of y to just get x. So then to get rid of y, I then need to match the coefficients on the two equations. So I have minus 2k on the bottom, so then on the top I need to times by 2 to get 2k to match. And then I can get rid of them by as I've done there by adding the subsequent equations. So then I get 7x to 21. Cool. So that's the strategy, right? The exam question guided me there by solving for x first, and then I needed to get rid of y, and hopefully seeing how I did that. Okay, cool. Part B then, it's saying, given that y is a half, so the told us the solution, right? Y is a half, and we know that x is a third. We already saw that. It says find the value of k. So again, we're going to substitute it then into one of the equations, right? So we know y and x, I can solve for k. So then let's substitute it into 1, right? Into the first equation, for instance, doesn't matter which one. So then we're going to have 3x, which could be 3 lots of 3, plus ky, that's k lots of a half, is equal to 8. Then I can solve it, well, a half k, right? Is equal, well, plus 9, right, is equal to 8. That's 3 times 3, which is 9. K times a half is a half k equals 8. Then I can say a half k is minus 1, right? Take away 9 to both sides. Then simply k is double. So times by 2 to get rid of the half is minus 2. And there we are. That's our solution. Great stuff. Okay, cool. So hopefully this question you can see we were forced to, we couldn't use the calculator there. We can use the calculator now because we found K to check our answer. But we had to admit there's a lot of algebra, so which means we couldn't really use the calculator. So we needed to eliminate the equations instead. And we eliminated y again because x was it told us to solve for x first. So that told us we need to get rid of the y bit. So I needed to match the coefficients on the both equations. There we are. I'm going to leave off with the exam question then. And it's this idea of modelling again, which I did a video on at the end of the last section of quadratics. So real life context with equations. So it says the height h meters. So I always underline the units h meters, t years is modeled by this equation. H squared is at plus b. Given that the height of the tree 2.6 meters, exactly 2 years, and the height of the tree was 5.1 meters, exactly 10 years after being planted. Find a complete equation to the model, given the values of A and B to 3 sig figs. So that's what, when it says complete equation, it's asking you to find any unknowns to the equations. So A and B are unknowns, right? So we need to solve that. So let's restate our equation. So h squared is at plus b. Um, I need to use the information given. So it's told us that the height of the tree was 2.6 meters, exactly 2 years. So, but then the time is two, right? Because t is in years, right? So t is two. H, the height is 2.6, right? As you can see there and there. Okay, and then when t is 10 in 10 years, the height then is 5.10. So we can write that as t is 10, h has to be 5.1. Well, I can then substitute these values into the equation, see what I get. So then if I substitute the first bit of information with t is 2, well, 2.6 squared, right, for h is at, that's going to be a lots of 2, add b. Put that 2.6 in the calculator, 2.6 squared, that is 6.76 equals 2a add b. Uh, okay, then for the other bit of information, when t is 10, h is 5.1, then 5.1 squared, by substituting it into the formula here, 5.1 squared is going to equal a lots of 10 plus b, then 5.1 squared becomes 26.01 is equal to 10a plus b. Cool. So that's really it. That's nothing more we can do there. But notice what we got here, right? These are simultaneous equations, right? Because we have two equations with two unknowns together. So A and B are in the two equations, but we have two equations with two different numbers, right? Two variables, two missing values, which are A and B. That means we can solve them simultaneously using substitution or elimination, which we did with the examples previous. So if I were to restate this, so this is equation 1, right? Then I'm going to have 26.01 equals 10a at b. I'll rewrite it downward like this next to each other. I think it makes it easier to see what I need to do. Okay, equation 1 and 2. So what would I do? I could substitute. Well, actually, I think it's a lot nicer if I take them away because I notice B is already matching on both equations. That's screaming to me. I can just, instead of bothering to substitute, I can just take them away to get rid of B as it is. So if I take the first equation by the second equation, that means 6.76 minus 26.01, which would be 6.76 take away 26.01 is minus 19.25. And that's going to equal 2a take away 10a, that's going to be minus 8a, b take away b, which is 0, so the b's cancel. So I could just, in this case, just take them away as it is, because the b's are matching, the coefficient is 1 on both of them, so I don't need to scale, I can just simply take them away. But then I've got an equation for a, so I can get solve for a to divide by minus 8, so minus 19.25 over minus 8, that goes to 2.40625. Uh, actually, no, I'll give it a fraction, right? 77 over 32. Okay. I know it says to round it to 3 sig figs, but I need to find B. So I need to substitute the A as exactly as it is to not get any rounding error. So I don't round too early, right? So I found A. So now I need to find B, right? And can substitute that into any equation, one or two. Let's substitute it into the first one. Okay, so sub A into equation 1. Then 6.76 is equal to 2a, which is 2 lots of 77 over 32, plus b. Um, then if you work that on the calculator, that's going to be 6.76 is equal to 77 over 16, which is double of 77 over 32, plus b. Cool. Then I can then get b to take the fraction to both sides. So 6.76 take away 77 over 16. That equals then, if we put that in the calculator, this number here, 1.9475. Okay. So that's a value of b. Okay. But then it says to give it the two values of three significant figures, so not as a fraction, but it wants us to round it instead. Well, to three significant figures of 194, then that's third significant figure. Then the seven tells me I need to round up to a 5, so 1.95 meters to three sig figs. And then I need to do the same for A, because A is 77 over 32, which is 2.40625. And for three significant figures, that'd be 2.41 meters to three sig figs, because the six will round to 0 up to a 1. Cool. Okay, so we've found our values, but then it says, remember, find a complete equation to the model. So we need to complete the equation, right? We can't just leave the values there and not fill it in. So we need to restate the equation to get the last mark to fill in our values A and B. So h squared, so A, remember, was 2.41 t, and then add B. B was 1.95. There we are. Cool, so that's our equation then. I'll circle that. There we are. Then it says for part B, I'll do it up here. Given that the height of the tree was 7, exactly 20 years after being planted, evaluate the model. So again, this is quite common. So this basically makes us scrutinise how correct or valid the equation is for the model. So we get given some data, some numbers, right? And so we need to put these numbers into the equation to see how close it is to the true answer. So it told us the height is 7, 20 years after. So let's substitute. We could either substitute 7 in to solve for t, but I think it's a lot easier just to substitute t20 in, right? And then I can get h quite quickly. So I'm going to substitute t20 in because that's telling us here to consider when the height at 20 years. So when t is 20, h squared is going to be 2.41 of 20 plus 1.95. That will go to 50.15. And then that's h squared, so therefore h is going to be the square root, not plus or minus, because height is positive in this instance. So it's just the positive root of 5.15, which would be 7.08 meters. It's a long decimal. I'm going to do it to three sig figs, okay? Because the first part of the question was three sig figs, so it makes sense to be consistent. Okay, 7.08. Okay, that's telling you what our prediction is by the model. Remember, it's just an estimate, right? At the end of the day, we are assuming the height takes this equation. That's not necessarily exactly how it is. But that's our prediction. So the model predicts that when the time is 20, the height will be 7.08. What it's told us in reality after 20 years is exactly 7. But actually, 7 and 7.08 is pretty close, right? So it's a pretty good model then. So to evaluate the model, it means just how good or reliable it is given the information you have. Well, the information is it's 7. Well, it's pretty close to 7.8. So I'm going to say 7.08 is very close to 7, right? So the model is uh, reliable, right? Uh, Reliable to predict the height of the plant, right? And there we are. Cool. So that's what you want to get at that. Essentially, that 7.08 is pretty close to 7. So it's a pretty good model, right? And that's essentially it, right? So that's modeling, right? So again, if it a common exam question, exam tip, if they give you some data and it says evaluate the model or how good the model is, plug in those numbers to see how close the answer is to the actual answer. So 7.08 is close to 7, so it's a pretty good model in light of that information. Cool. That's it then. So that's simultaneous equations, but I will leave that there.